Good morning, scholars. Today we're going to be talking about scaling factor and how that works with perimeter area, volume, and surface area. So first and key things to remember, so scale factor, this refers to the number, usually represented by K, in a dilation, which is a number by which you're making the plane smaller or bigger, or three-dimensional space or whatever. So sometimes you might see this represented as d sub little k, d for dilation, and then k for the scaling factor. All right, so our problem today is we're going to enlarge this rectangle by a scale factor of 3. So that means we've got a dilation, it's making things bigger by 3. We want to describe the effect on the perimeter and describe the effect on the area. So it can be helpful to make a picture of what's actually happening. So it's said that we're going to enlarge, so our dilation is going to make things bigger. So here's just our little map for our dilation. Scale factor is 3. And then what's going to happen is this thing is actually going to get bigger, this rectangle. And what happens to the side lengths is they actually get multiplied. So you would take the 1 times 3, you get 3, you take the 4 times 3, you get 12. Now, the effect that this has on the perimeter is everything got bigger by 3. And since perimeter is a length, that means it has one measurement. What's going to happen to the perimeter is it's going to be multiplied by 3. Now, what's going to happen to the area, because area has, so just right in here, length has 1 dimension. Area actually has 2 dimensions. So if you're talking about units, you'd be talking about something like centimeters squared or feet squared, something like that. So I'm just going to write 2 dimensions next to area. Now what that means is that both the 3 the 1 in the original got multiplied by 3, and the 4 also got multiplied by 3. So the 3 kind of got multiplied twice. So what that means for area is it's going to be multiplied by 3 squared. And usually this actually works out. So the number up top is corresponding to the dimension, and then the scaling factor is the base of your exponent. So here you could rewrite this as 3 to the first for length, which only has 1 dimension. So another kind of application of this is to volume. So in volume, you actually have 3 dimensions, right? So you've got the height, the length, and the width. So that's 3 different dimensions. So we're looking for a number multiplied by some number raised to the 3rd power, because there are 3 dimensions. So we've got to take our original 50, we're multiplying it by something to get 400. So we can write an equation. So 50 multiplied by some unknown number, usually call it x, to the 3rd power is equal to 400. And then you're going to solve that for x. So divide both sides by 50. Get x cubed is equal to, zeros cross out, 40 divided by 5 is 8 last time I checked. So you get x cubed equals 8. Now you take the cube root of both sides. Oh, algebra, so much fun. It's awesome. So you get x is equal to 2. So the scaling factor for number 1 is 2, which is what we were supposed to find. And I guess I actually should have been using k here instead of x, but what you gonna do? All right, that should set you up well to finish the rest of the worksheet. If you have questions, let me know. Bye.